Hi, I'm Eric from Island Energy Systems, and today I'm going to show you an off-grid solar electric system. This is a system for a year-round residence, and it's got three major components: the solar array on the roof, the power center, and the battery. And I'll talk about each one of those, and we'll look at the different parts and show you how it all works. All right, let's look at the PV array on the roof. These are photovoltaic modules. There are 6 of them. They're 200 watts each for a total rated power of 1200 watts. Now what that means is when the sun is directly overhead at high noon, this array should produce about 1200 watts of power. The amount of time that the sun shines on them will determine how much energy the array will be able to produce in a given day. And that varies based on the time of year, obviously. And this time of year we get about 5 hours of peak sun per day, and so this array should produce about 5 to 6 kilowatt hours of energy to charge the batteries every day. This array is flush mounted to the roof. It's lag bolted into the rafters, and then those mounting feet are attached to aluminum rails, which then the modules are clamped down to from the top. The array is broken into 3 pairs of modules. Each of those pairs is wired together in series, and then those 3 sets are brought together in the combiner box there on the right side of the array, which combines the output of all of the modules into one set of conductors, one set of wires that carries the power down to the charge controller and into the battery. Next, we're going to go look at the power center, which has the charge controller and the inverter charger in it. The power center is composed of 2 major electronic components and then this enclosure which houses circuit breakers and wiring. The PV charge controller is this box over here, and what it does is it takes the power coming from the solar panels on the roof and regulates that power and conditions it to charge the battery appropriately. It regulates the voltage, it watches the voltage of the batteries so that the batteries don't get overcharged, but it provides the right multi-stage charging to condition the battery and keep the battery in its best condition. Once the battery is receiving that charge then from the solar, and then this guy here is the inverter charger, which allows us to use the power stored in the batteries for running regular loads. And it's basically 2 components in one. The inverter means it can take the DC, the direct current energy stored in the batteries, and pull it from the batteries and create alternating current to run the loads. This one can run up to 2.5 kilowatts of AC loads continuously. And for starting motors and things that require a large surge current, it can go about twice that for a few seconds to get motors started, that kind of thing. It also has a charger built into it, which basically means it takes the inverter and it runs it in reverse. It has, if you have AC coming from a generator, you can turn on the generator, and then this will take the power from the generator and use that to charge the batteries, DC current appropriate to where the batteries are and what they need for fully charging. This enclosure that they're mounted on is our power center enclosure, which has circuit breakers, wiring, a few metering control types of equipment inside of it, and it puts the whole thing in a real nice package that makes it easy to install, easy to be compliant with the National Electric Code, and very safe and nice, clean looking installation. Okay, well that's it for the power center. So let's close it back up and we'll go inside and take a look at the battery. Alright, so here's the battery. This is a deep cycle industrial quality battery. It's composed of 12 2-volt cells, all wired in series for a 24-volt system voltage. These are very heavy-duty deep cycle batteries designed for long life and deep discharges. They're flooded lead-acid batteries, so that means that there is liquid electrolyte inside the batteries that it will be turned into hydrogen when the batteries are charging. When the batteries are charging, there's a chemical reaction in there that causes the hydrogen gas to be produced. So this box has a sealed lid which goes down on it to keep the battery gases from coming into the building, and it has a vent pipe which allows the gases to escape outside so that it doesn't create corrosive environment inside the building. Batteries are the element of the system that does require the most amount of attention from the system owners and occasional maintenance. Basically, for this system, what that means is just keeping an eye on the water and adding distilled water as necessary as some of that electrolyte is bubbled off and turned into hydrogen. So there you have it. That was a tour of an off-grid solar electric system. This is Eric from Island Energy Systems. Thanks for watching.